using trig equations, and we're going to be in degrees. And then if we ever land on a quadrantal over here, so if a solution's ever over here, we're going to use that as 0 degrees. So we have the inequality to where we're equal to 0, but not equal to 360. So this could be either 0 degrees, right, if we start it, or 360 if we end it, right? But we are always going to use it as 0. So that's what this little notation is telling us, is that if you ever have an answer over here on the positive x-axis, you want to make sure that you just answer it as 0 degrees and not the 360. So the beginning of the notes here, this is just a review off of the previous objectives. So making sure that we know that sine of theta is equal to y over r, but we're going to have our radius equal to 1. So we can also view that as sine of theta is equal to the y value. And then over here, our cosine theta is going to be equal to the x value, right? Because our radius is equal to 1. And then tangent, of course, is y over x. And so then also just reviewing, because sine is the y value, when we go up on the positive y-axis, that is where sine is going to be positive. And then if we go down on the y-axis, that will be where sine is negative. And then also for cosine theta, so because cosine theta is the x value, when we go in the positive x direction, that is where cosine will be positive. And when we go in the negative x direction, that will be when cosine is negative. And that will come into play to help us for the solving. And then remember, tangent is y over x. So similar to that would be our slope, right? Delta y over delta x. So if we can draw a positive sloped line, that would cut through quadrant 1 and quadrant 3. So that is where sine is positive. And then if we were to draw a negative sloped line, that would cut through quadrants 2 and 4. So that would be where sine is negative. And then we're going to be using our special right triangles to help us figure out like what are the different ordered pairs. And so if we are at 30 degrees, so let's say 30 degrees is right around here, then at 30 degrees, I would go to the right, root 3 over 2, and up 1/2. So at 30 degrees, this ordered pair would be root 3 over 2 and then comma 1/2. And then for the 45 degrees, so we'll just say this is 45 degrees right here. So that ordered pair, so if this is 45 degrees, so I'm going over 1 over root 2 and up 1 over root 2. And remember, that can also be the radical in the numerator. So if I rationalize the denominator, so that would be root 2 over 2 and root 2 over 2. So either answer would be acceptable. It doesn't really matter which one you're going to do. And so I should probably label. So that was 30 degrees, that's 45, and then finally at 60 degrees. So that would be this triangle, but we're going flipped around. So I'm going to just redraw that same triangle. So 60 degrees, though, I'll put over here. So across from the 60 is root 3 over 2, and adjacent is 1/2. So then when I go from the pole, so that would be right here, the origin, I'm going across the triangle of 1/2 and up the triangle of root 3 over 2. So then I can also look at this ordered pair as 1/2 root 3 over 2. So different ways to solve these triangles. You can memorize what they call the unit circle. You can work off of your triangles, whichever one your teacher's going to emphasize, okay? All right, so let's go ahead and take a look at the first part here. So this is asking us to identify our quadrants where the terminating ray would lie. So essentially what it's asking you, so another way to think about this question is they're asking you, when is your trig ratio greater than 0? So they're essentially asking you, when is the trig value, the ratio, going to be positive? So that's what all of these questions are asking us right here, okay? If it's greater than, right, so greater than. Or if it is a less than, right, less than symbol, then it's asking you for where is it negative. So that's really the way we're thinking about it. So when is the trig value or ratio positive? When is the trig value negative? And that's going to be based on the sign. So right here, when I'm reading this question, sine theta greater than 0, this is asking you, what quadrants, is sine's ratio going to be positive? So where is sine positive? That's what that question is asking us. So I know that sine is the same as a y value, right? So sine is a y value. So when is the y value greater than 0? So if I look at the x and y axis, right, so sine is a y value. So on the y axis, which direction do I need to head to get to positive values? Well, I would head up. So that means my answer is going to be here in quadrant 1 and in quadrant 2. So that would be quadrant 1 and quadrant 2. So right here, this is asking for where is cosine less than 0. So where is cosine negative? And remember, cosine is the x value. So where will I have to head to get to negative values of x? So this is my x-axis. So which way would I go to get to negative values of x? Well, I would head left. And so that means cosine would be negative on the left side over here. So that would be in quadrant 2 and quadrant 3. Okay, so right here, this is asking for where is tangent less than 0. So when is tangent negative? And remember, tangent is y over x, so that's like our slope, right? And so that means I want a slope that would be negative. So how would I draw a negative slope through the origin? It would be right here. So this is a negative sloped line, so that is where tangent is negative. So here and here. And so that's in quadrant 2 and 4. So then for this last one, it's asking for sine squared greater than 0. Well, this one's kind of a tricky one, right? So sine squared being greater than 0, that means that sine is my y value. So when I square the y value, it's going to be positive. Well, when I square any number, it's always going to be positive, right? So if that was 2 squared, that would be positive 4. If it were negative 2 squared, also positive 4. So that means it's going to be positive everywhere because whenever I square a number, it will always be greater than 0. Well, with the exception of 0, right? So that would be quadrants 1, 2, 3, and 4. And then, so that would be all 4 quadrants is where when I square something, I would get a positive value. Okay, so let's go ahead and take a look at question number 5. And I'll be referencing our triangles up here. So make sure that you're kind of paying attention to those things here. Let me erase this guy because I don't need that little scribble. Okay, so let's take a look at step 1. So step 1 is asking us to isolate the trig ratio. So the trig ratio is your sine, cosine, tangent. So that means we want to get cosine of theta by itself. That's what that means when it says to isolate. So that means the 2 and the 1 that are around it need to go to the other side of the equation because we want to isolate that. So I'm going to start with adding and subtracting. So I'm going to subtract 1 from both sides because 1 minus 1 would be 0. And then I'm going to divide by 2, right? So we're trying to isolate the trig ratio. And that's because there's an implied multiplication there. So then 2 divided by 2 is 1. So 1 cosine theta equals negative 1/2. The second thing we want to do is we want to find the reference angle. So we want to find theta prime. So we're going to figure out the reference angle. So this won't be my final answer for theta. It just gets us in the right category. So this is asking for, what triangle should I be using? So where would cosine be equal to 1/2? So that's what I'm trying to figure out. And I know that cosine is adjacent over hypotenuse, right? So adjacent over hypotenuse. So I'm going to go ahead and take a look at my triangles here. So these are my only choices, right? So my answer has to be 30, 60, or 45, right? So I have a 1 in 3 chance of getting that right, unless it's on a quadrantal, right? So it's either got to be 30 degrees, 60 degrees, or 45 degrees. And so I was specifically looking, though, for where is cosine equal to 1/2, right? Or negative 1/2, but we get the negative the direction later. So that means I have a 1/2 right here. So then my answer is either 60 degrees or 30 degrees. And I know cosine has to be adjacent, right? Adjacent over hypotenuse to the 1/2. So which angle is adjacent to the 1/2? And that would be the 60 degrees, right? So 30 is opposite of the 1/2, but 60 is adjacent. So then that means my reference angle is 60 degrees. So then now my next step is I want to draw the terminal rays. I have to draw out my terminal rays in appropriate quadrants based upon the positive or the negative of the ratio, right? So when I draw in my terminal rays, so I'm just going to sketch this out right here. So I know this is 0 degrees, 90, 180, 270, and 360. So I know I'm going to be using my reference angles, so that means I won't be using 90 or 270. So from here on out, I'm only going to be using the 0, 180, and 360 because we're going to be working with a reference angle, right, which is the distance from the x-axis. So I'm not going to ever label the 90 and 270 again. So what quadrants should I be in? So I had a negative ratio. And I know that cosine, remember, is the values of x. And so which way do I go to head to negative x values? I head to the left. So that means cosine is negative in quadrants 2 and 3. And I can also, if I forget or if that doesn't make sense, I can always look up here, right? So where is cosine negative? To the left. And so then now my last step is now I have to find my rotated angles, which is theta. So now I'm going to actually find my final answer. So theta prime is just my reference angle, which is the distance to the x-axis. So theta is my rotated angle, and it's a rotated angle meaning from 0 degrees. So I know I have to figure out, well, how far is that rotation? Well, I know my reference angle is 60, so this amount here is 60, and then this has to be 60, right? So that gap there. So theta then, so I did not make it all the way to 180 degrees, right? I stopped before I got to 180, and I stopped by 60 degrees. So this angle right here, so I'm going to call this theta 1, so I'm going to use the subscript, is I did not make it to 180. I stopped before I got there, and I stopped by the reference angle amount, which is 60 degrees. So that would be 120 degrees. And then now let's find my second angle. So I'm going to use a 2 down here for my second angle. So for the second one, so from 0 degrees, so here's 0 degrees, I rotated past the 180 and got to here, right? So past the 180, and I'm always going to go either before or after the x-axis by the 60 degrees because that's my reference angle. So for theta 2, I went past the 180 by 60 degrees. So I'm more than 180, so I'm going to add 60. So 180 plus 60 is 240 degrees. And so then my answer are those two rotated angles. So I would just write theta is 120 and 240 degrees. So that can be a little confusing. So you may want to, press pause, try to do that problem on your own before we go to the next one and see if you can kind of make sense of that, okay? All right, let's take a look at, we're going to jump to number 7. I'm going to come back to 6, but we're going to, oops. So I'm going to go to 7 first, and then I'll come back to the tangent ones. Okay, so step 1 is isolate the trig ratio. So we want to get that by itself. So that means I need the 2 and the square root of 3 over to the 0. So I'm going to start with the adding and subtracting. So I'm going to add the square root of 3 to both sides. So that would just be 0. And then now I need to divide the 2 over. And again, that's because I'm trying to isolate the trig ratio. And then now I want to find theta prime, which is my reference angle. So I'm looking for where sine is equal to the square root of 3 over 2. So I'm going to go back up to the triangles here. So I'm looking for the square root of 3 over 2. So let me erase that. So where is the square root of 3 over 2? It's right here. And I know that sine is opposite, right? So sine is opposite over hypotenuse. And so which angle is opposite of the root 3 over 2? Well, that one is adjacent. So opposite of it is the 60 degrees. So that means my reference angle is 60 degrees. And then once I do that, I can see that sine is a positive ratio. And so now I need to figure out, okay, what two quadrants should I be in where sine would be positive? And I know that sine is the y, right? So sine is my y value. So which direction would I go to get to positive values of y? So to get to positive y's, I would go up. So that means sine is going to be positive when I go up. Okay. So then for my terminal rays, I'm going to draw them in quadrant 1 and quadrant 2. And again, that's because I know sine is my y value. I know the ratio is positive. So I would go up. And then this is 0 degrees. I don't need to label the 90. And then this is 180 and then 360. So then now once I find my reference angle, which I did, and what quadrants I'm in, now I'm going to find my rotated angles. So from 0 degrees, how far did I rotate to get to here? Always the reference angle. So that would be I just rotated 60 degrees. So in this case, my reference angle is going to be the same as my first rotated angle, and that's because I'm in quadrant 1. And so that will always happen when we have that, okay? And then now I have to find my next rotated angle, so this one right here. And so I'm 60 degrees away from the x-axis because that's my reference angle. So to find my second angle, I did not get all the way to 180. So I know the answer over here has to be smaller than 180, right? So this has to be smaller than 180. And then how much smaller is it? It's going to be 60 degrees smaller. So then I would do 180 minus 60, which would be 120 degrees. Okay. All right, so I know I'm jumping around a little bit, but that's okay. We can do that. Okay, so let's go ahead and we're going to take a look at number 9. I'm going to do the tangents last. Okay, so step 1, we need to isolate the trig ratio. So I need to first get the sine squared by itself. So I'm going to do my adding and subtracting first. So I'm going to add 1 to both sides, and then that gives me 0. And then sine squared is the same thing as sine theta quantity squared. So I'm going to rewrite it right now. And then 0 plus 1 is 1. Still working on that isolating, right? So now I'm going to get rid of the 4 by dividing over the 4 because 4 divided by 4 is 1. Not done isolating, right? Because now I have that squared. So we did a whole chapter on, solving by square rooting. And so that's what we're going to do next. So we're going to solve by square rooting. So we're going to square root both sides. And so then remember, so this is been a while, but the square root of something squared is absolute value, right? And then the square root of 1 is 1, and the square root of 4 is 2. So if you also remember when we were talking about our absolute values, that means we're going to have where sine theta could either be positive or it could be negative, right? So then sine theta could either be positive 1/2 or it could be negative. So I could just do that plus or minus, right? Because the absolute value of negative 1/2 is still 1/2. All right, so let's, once we're isolated, now we're going to find the reference angle, so theta prime. So we're looking for where does sine equal 1/2, right? Where does sine equal 1/2? So I'm going back to my triangle. Really need to know these, right? So sine, where is it equal to 1/2? So in this case, I'm looking for 1/2, and I know sine is opposite. So which angle is opposite of the 1/2? Is that the 60 or is that the 30? And so in this case, 30 degrees is opposite of the 1/2. And then I'm going to do a little bit of erasing while I'm right here. So then I know it's going to end up being 30 degrees, right? So 30 is opposite of the 1/2. So then now sine again, remember, is your y value, right? Your y value. So I want to go to, where would I go to first for where Do we have positive y values? So positive y values is when I go upwards. And then where will I have negative y values? Well, that will be downwards. And then let's label the x-axis, so 0, 180, 360. And I know the reference angle is 30 degrees. That means each of these angles are going to be 30 degrees away from the x-axis. So then now I have to find my rotated angles. So we're going to start with the quadrant one. So I'm starting at 0 degrees and I'm going to rotate till I get to that one. And when do I stop rotating? At my reference angle, 30 degrees. So now let's go ahead and find, erase this line right here. Well, that's not the line I was trying to erase. That's okay. All right, so now let's go ahead and go to quadrant 2. So I'm rotating. How far do I rotate to get to here? So what I do know is I didn't make it to 180. I stopped before I got to 180. And how many degrees did I stop? I stopped by my reference angle amount, which is 30 degrees. So I stopped before 180. So I'm going to subtract my reference angle. And so then quadrant 2, beta, so quadrant 2's answer is going to be 150 degrees. 2 more though, right? I got to find 2 more. So we're going to start from 0, and I'm going to rotate past 180 until I get to quadrant 3, right? So I started at 0, going past 180 until I got to quadrant 3. Well, how far past 180 did I go? I went the reference angle amount, so 180 plus the 30 degrees. So then that third one will be 210 degrees. And then finally, for the last one, so the last amount is, so I have to get all the way over here into quadrant 4. So I'm going to start at the 0, going past the 180, and then I'm going all the way over to here, right? So I did not quite make it to 360. I got close to 360, but not quite. So how many degrees did I stop before I got to 30? Or before I got to 360, I stopped 30 degrees before, which again, that's my reference angle. So that reference angle tells us how far past 180, how far, past 360, or before I got to 360, or before I got to 180. So that is what always that reference angle is telling us. Did we make it to the 180? Yes or no? So should I add or should I subtract? And I got myself into trouble by talking and writing at the same time. So that would be 330 degrees. So in this case, I have 4 answers because I was in 4 different quadrants. Okay, and then the absolute value as well. All right, so we have one more that's not a tangent, and then I will go back and do the tangent. Okay, so for here, I have a product equal to 0. So that means I'm going to use 0 product property. So 0 product property means that one of these factors has to be equal to 0 in order for the product to equal 0. So then I'm going to just set each equation equal to 0 and then solve for those. So I'll start with this one over here. So I'm going to add 1 to both sides because remember, my first step is always to isolate the radical. Oops. And then I'm going to divide both sides by the square root of 2, right? We always want to start with that adding and subtracting first, and then we go into our coefficients and can we multiply or divide the coefficient away. So I have 1 over the square root of 2. So let's find the reference angle first. So I'm going to look at my triangle. So I'm looking for 1 over the square root of 2 or root 2 over 2, right? So in this case, 1 over root 2 here, and then sine and is opposite. So this one, it really doesn't matter if I know opposite versus adjacent because they're both 45 degrees. So that kind of is, all right, so it's a 45 degree. And so now sine is positive. So I'm looking for where would I go for sine to be positive? Remember, sine is the y value. So which way do I head to get to positive values of y? I would head up. So I would be upwards in quadrant 1 and 2. And then I'm going to label. So this is 0, this is 180, and then 360. My reference angle is 45 degrees. So the distance from the x-axis is 45 degrees. So now we're going to find our rotated angles. So our rotated angles always start at 0 and we're headed upwards. So how far do I go to get to the first one? And that would be I head 45 degrees. And then now I need to head to quadrant 2. So again, I'm starting at 0 and I'm headed over to quadrant 2's rotated angle. So this one I stopped before I got to 180. So it can't be bigger than 180. It has to be smaller than 180. So then should I add or should I subtract the 45? Well, if I want it to be smaller, I'm going to have to subtract the 45. And so that would give me 135 degrees. Okay. All right. And then for question number 10, so I want to solve this one here. And so I would isolate the trig ratio. And this one I'm not going to solve all the way. We're just going to do part way. And then you can solve it on your own. And then divide by 2. So I will let you find theta prime because we've already done a root 3 over 2. And then where is sine negative, right? So sine is negative where y values are negative, so headed down. So you figure out what is that theta prime. And then you figure out what is the rotated angle into quadrant 3, and then what is the rotated angle into quadrant 4. So you guys figure out both of those and see what you get on that, okay? And so hopefully what you got was 240 and 300, and that was 60. Okay. And now let's go ahead and take a look at those tangents. Oh, so let me mention here. So all 4 of these answers would be the solution to that equation. All right, so tangent problems. Okay, so similar. So we're going to isolate. So I need to get tangent by itself. So I'm going to add 3 to both sides. And then divide by 3. And that would give me a positive 1. So I want to find my reference angle, and then I want to find my rotated angles. So where would tangent equal 1, right? Where does tangent equal 1? So I have to look up here at my triangles. And so I know that tangent is opposite over adjacent, right? So tangent is opposite over adjacent. So this one can be a little bit trickier. So, you might want to just memorize, but that's okay. So if I go to the 30 degrees and I do opposite, so that would be this one, and I divided that by the adjacent. So if I took the 1/2 and divided it by the adjacent and multiplied the 2, I would get an answer of 1 over root 3, which is not 1, right? So in order for a fraction to equal 1, the numerator and the denominator has to be the same. Well, 1/2 and root 3 over 2 are not the same, but 1 over root 2 and 1 over root 2 is. So that means that tangent is going to equal 1 always on a 45 degree. So then that means my reference angle is going to be 45 degrees. So now for my rotated angle, so where does tangent equal positive? So I need to know tangent is slope, right? So like y over x. So I want to draw a positive sloped line. So that would be through the origin, that would be up into quadrant 1 and down into quadrant 3. So then let's label my x-axis at 0, 180, and 360. And then now we're going to find our rotated angles. So our reference angle is 45 degrees, so that means we're 45 away from the x-axis. So let's rotate into quadrant 1. So from 0, how far did I rotate to get to the first one? Well, I rotated the reference angle amount, so that would be 45. And then now let's rotate from 0 degrees into quadrant 3. So from 0, I'm going past 180. I'm going past 180. And how far past 180 did I go? Always the reference angle amount. And then I'm bigger than 180, so that means I want to add. So then my other angle would be 225 degrees. Okay. All right, and then let's take a look at question number 8. So same-o, right? So we want to isolate the trig ratio. So I'm going to add 3 to both sides. And then I'm going to go ahead and rewrite that tangent squared as quantity squared. And then now to get rid of the squared, I'm going to square root both sides. And then that will give me the absolute value of tangent of theta. But then I know with the absolute value, that means I could have that be positive root 3, because if that was positive root 3, it'd still be positive. Or I could have it be negative, because the absolute value of a negative is positive. So that's very much like the previous, or one of the previous problems that we did. So then from here, I want to find my reference angle and then my rotated angles. So I'm going to go and I'm going to put this over 1 to help me think about that a little bit more. So tangent theta, when will that equal root 3 over 1? Well, it's got to be either 30 degrees or 60 degrees, right? Because that's the only one that even has the square root of 3 on it. Okay, so I want it to equal root 3 over 1, right? That was what my goal was. So if I know tangent is opposite over adjacent, so if I chose the 30 degree and I did opposite over adjacent, the 2's would reduce and I would get 1 over root 3, which is not what I wanted, right? That's upside down of what I wanted. So 30 was no good. So that means it's probably 60. So 60, opposite of 60, and then adjacent to 60. And then the 2's would reduce, and then I would get root 3 over 1, so that was my goal. So I know my reference angle is 60 degrees. So now let's find my rotated angles. And since we're looking for where tangent is positive and negative, so it would be positive on the positive slope line, so that would be quadrants 1 and 3, and then negative on the negative slope line, so that would be quadrant 2 and 4. That means I have to find 4 angles, right? And so I'm going to go ahead and mark my x-axis. And then I know all of the reference angles, so all of these little angles in here are all 60 degrees. Put a little dot there for the degree. So then now find my rotated angle. So from 0, I'm going to rotate into quadrant 1. So I rotated just the reference angle amount. And then now I want to rotate into quadrant 2. So I'm going to start from 0, and then I'm going to go to quadrant 2. And did I make it to 180? I did not. So should I add or subtract the 60? So before I get to 180, smaller than 180, so then I want to subtract. So then my second angle would be 120. And then now for my third angle. So I'm starting from 0. I'm going past 180 until I get to the quadrant 3. So I started at 180 and I went past it by 60 degrees. So do I want to add or subtract? I'm going to add because I want it to be larger. And then finally for my fourth one, so the fourth one, I'm going to go all the way into quadrant 4. And I stopped before I got to the 360. So before the 360. So what do I do with the reference angle? Do I want to add it or subtract it? So before the 360 means smaller than 360, so I want to subtract. So then my last answer is going to be 300 degrees. And that gives me all 4 answers, right? So I'll get 4 answers on those pluses and minuses, or 4 answers if it looks something like question number 10. And that is the end of that one.